This problem doesn't provide mass values. Instead, the mass to mole conversion has already been completed for you. This is super convenient, but only if you realize that is what is happening. Always carefully read the question and review the units included so that you know what's given to you. While I know the types of atoms present and how many moles of each there are, the moles given aren't really in a usable form because our chemical formulas will never ever look like this because these values are not whole numbers. But we can divide each of these whole numbers by the smallest among them, which is 0.14. Remember, one larger mathematical operation, and what you do to one part of an equation, you have to do to all the other parts of that equation. So all three subscripts will get divided by the same 0.14 value. This leaves us with 1.5 zinc atoms, a phosphorus atom, and 4 oxygen atoms. Now we've gotten closer, but this is still no good. We're looking for the smallest whole number ratio, so I need to get rid of the 1.5, or that 3 halves. Again, one larger mathematical equation, so we will do the same thing to all of the pieces. Since multiplying that 3 halves by 2 will cancel the 2 in the denominator, I will have to multiply all 3 subscripts by 2. Doing so leaves me with the smallest whole number ratio of my atoms. In reality, we're still not really done. Since this has a metal present and we're in a Gen Chem class, it should be assumed that zinc is acting as a cation in an ionic compound. This in turn means that it's going to interact with an anion, and there wasn't a P2O86 minus anion in our table of polyatomic ions. But there was a PO43 minus anion in that chart. And if I doubled that PO43 minus anion, I would have the same atom count. So this compound is best written as zinc 3PO42.